It's me, Vikas Kumar Gupta, and my friend Varun Gaura. We both are from MS Ramaya Institute of Technology. We both are final year students, and we're gonna give you a small tour on Wireshark. What actually Wireshark is, how you use it, how you install it, and why you basically use it. So Varun gonna tell you what actually Wireshark is.
Wireshark is basically a packet sniffer. We can use Wireshark to analyze the packet sent and received from your computer and sent from your computer. You can basically analyze all the different packets and protocols through Wireshark.
Okay, so let's go to the tool now. We're gonna show you how to install it and a few examples. I hope this will be helpful for you guys. Thank you.
Okay, so let's start with the video. As you can see, few websites are there. This website is the main Wireshark website. Then from where you can download the documents, and this also some Wireshark document, and this is the FAQ, frequently asked questions, HTML. You can download all this page, which will help you related to learn Wireshark properly. So in this manual, we'll be using the Wireshark packet sniffer. Okay, here to display the content of message being sent or received from or by protocols of different level of protocol stack. So technically speaking, Wireshark is a packet analyzer that uses a packet capture library in your computer. Wireshark is a free network protocol analyzer that runs on Windows, Linux, Unix or Mac computers. It's an ideal packet analyzer. It is stable, has a large user base and well documented support that includes a user guide. As I told you, this is the user guide. From here you can download the document which will support you. Okay, so let's get back to the installing part. So from this URL you can download the setup file of Wireshark. I've already downloaded it. I'll show you the installing part. So let's go to the Wireshark folder. Here it is. So this is Wireshark. Okay, this is the setup. Now I'll show you how to download it. It's all easy. You just have to click yes, yes, next. That's all. So yes, see, next. I agree. Then these are the files which it will download or install in your computer. So next, you will have to press next. Let's go back here. Yeah, desktop icon. You want a desktop icon. Go next. This is where you can download it. You can actually change it also from here, wherever you want to install it. I'll go with this. And this is a library. Okay, this basically is the library. So you basically have to install it also. So now it's installing. In order to run Wireshark, you will need to have access to a computer that supports both Wireshark and the library. The library basically is WinPCap or libpcap capture libraries. Okay, the libpcap software will be installed for you. Okay, as I told you. So this is already installed on my computer, so it's asking me to replace it. Yes, I will. So it will install the WinPCap, the packet library. Okay, still it's downloading, sorry, installing. So it's done. Run Wireshark. I'll run it. I'll tell you how to do it. Let's go easily. Okay, so this is the user guide. If you want to update anything, I don't need anything. I have everything updated now. So now let's just start. First, you have to decide the interface. Okay, like which kind of network you are using. So here I'm using the wireless network connection. So I'll click here. Start. Now see, now you are seeing some file, something is going on. I know this is hard to understand, but I'll explain you what all parts are. So let's see, the first part, as you can see the mouse, this first part is called the command menus. What is command menus? Command menus are standard pull down menus located at the top of the window. Okay, of interest to us now are the file and capture menus. The file menus allow you to save captured packet data or open a file containing previously captured packet data and exit the Wireshark application. The capture menus allow you to begin packet capture. Okay, and you can see everything you have there. You just take your, see, as you can see everything. I'll tell you what actually these things are, but let's go down first. Now we have the second part of this Wireshark screen is this one. So what this one is packet listing window. Oh, I'm sorry, this is display filter specification. Okay, what is display filter specification? Yeah, like there are so many different kind of TCP, UDP, DNS, these type of packets will be here. Whatever you want to find, you can search it here. Like if I want all the HTTP file to be on the screen, so I'll type HTTP here, enter. Now see, all the HTTP files are here. If you want to see UDP files here, so you just type UDP and see all the DNS UDP things are there. Actually no UDP file we are supporting now. Let's search for DNS. See, all the DNS protocols are here available. Now the third part, the third part is listing of capture packets. Okay, so it displays a one-line summary for each packet captured, including the packet number assigned by Wireshark. This is not a packet number contained in any protocol's header. Okay, the time at which the packet was captured, the packet source and destination address, the protocol type, and protocol specific information contained in the packet. The packet listing can be sorted accordingly to any of these categories by clicking on the column name. Okay, as I told you earlier, the protocol type field lists the highest level protocol that sent or received this packet. That is the protocol that is the source or ultimate sink for this packet. As you can see everywhere, see, whatever I told you now, you can see everything. This is the source address, destination address, protocol, the length of the packet, then a little bit information about the packet. Now come to this area. This area is called the detail of selected packet header. Now see, if you select one packet here, let's say I'll go for this packet. Everything about that packet, you just open the plus menu. Okay, anything you'll open, you'll find out all the details about that particular packet here. Okay, let's change the packets. You'll see the changes in the particular thing. You're gonna see like all details. You just open it, you'll find out everything. Now the last part is packet control and hexadecimal, like packet content in hexadecimal and ASCII number. So when you click in one particular packet, what actually the packet is containing is in ASCII address, it's here. Okay. Now this was all the installation part. Now let's have a look on few examples which might be helpful. So I'll close it here, good without saving because I don't do anything. Now let's go to your favorite browser. I'll go here. Okay, here we are in the Google page. Let's wait here for some time. I can explain you two examples. After that, my friend Varun will explain you the other examples. Like these examples are basic related to the HTTP files. Okay, so what you do, you first open your browser. Make sure your cache, like browser cache, are clear. Okay, so mine is clear already. So let's have a look on one example. Now the browser is open. You go to the Wireshark. Okay, don't do anything. Now you have to go to capture. See, in this window you have different options. This is the connection, which connection you are using. So wireless area connection I am using. Now what this part is, like in this part, okay, like all are by default, but you have to make one small change here. You just have to untick it, because like if you take it, you won't be able to see like how many particular packets, like how many UDP packets you are using in the communication, and how many HTTP packets you are using, so just hide it, you will see the difference later. So start. Okay, now there is nothing because there is something going on because the Google page is open. So I'll close it. I'll close this also once. Let's go to the file. No, not the file, sorry. Capture option and start it again. Okay, again something going on. This is for HTTP. You have a link. See, these parts are done. Okay, in HTTP, first example I'm showing you retrieving long documents. Okay, so the URL, you copy the URL and you'll see the changes in the Wireshark. You paste it here. My internet is a bit slow. Okay, now it's done. Now you go to the Wireshark, stop packet capturing. Okay, now this is your final for the HTTP. This is your final packet communication which you have done. So from this you can see all the data is related to the packet. Okay, so it's too many, so like you are using HTTP, so let's go to all the HTTP files which you have used. Oh, sorry, this is what happens if you write something different. So, HTTP, these all are the HTTP files which you have seen over there. So now see, as you can see, they are get files. See, get host name, address, like this is my IP address, this is the server's IP address, this is the two get message. You will like in the communication you will have two get messages. So first one is this, second one is this. Now let's see few questions which they can ask from here. So like see, they are asking how many HTTP get request message was sent by your browser. So how many get request message you can see from my host I'm sending 1 and 2 get messages I sent. Okay, these are the receive messages, so 2 basically. Then the second question may be asked, how many data containing TCP segments were needed to carry the signal HTTP response. So how many data segments you needed, so you can count those basically. See, 1 2 3 4. So how many we needed? 4 packets. 4 packets we needed data segments to carry the HTTP signal. Now what is the status code that was associated with the response to the HTTP get request? So what is the message basically? This is the message. Okay, so 200. Okay, 200 is the segment number, maybe. No, 200 is the number and okay is like everything is 200 is the segment number, it's some code, and like okay is like everything is okay in this like in this particular communication. Now are there any HTTP status line in the transmitted data associated with the TCP reassembled segments of a PDU? So can you see any HTTP status lines? So see, there is no HTTP status line. It's all HTTP get response message. So answer will be no. So these are like few frequently asked questions related to this HTTP, related to long documents. We have few questions. Now see, the like all detail about the hypertext link protocol. You can get information from here. All the data as I told you. See, then TCP, all the detail about the TCP you can get from here, the sequence number, acknowledgement number, and detail about the flags. You just have to open each one by one. This is the detail of the flag of all the TCP. Then you can get checksum, detail about checksum, good checksum, bad checksum. You have it here as you can see. So now all the like IP version, which IP version you are using. So I'm using IP version 4, and my like this is my IP address, and This is the server's IP address, 20 bytes. The header length is 20 bytes, etc., etc. You can have a lot of data from here. So let's see one more example related to HTTP only. So clear everything. Remove this also. Now the other example will be related to the like, I'll show you what it is. Yeah, it's the basic yeah, the basic HTTP GET RESPOND interaction. This is the basic one. So you're gonna need this particular URL. So do the same thing. Let's go here. No, first you have to open Wireshark. So here's the Wireshark interface list. Wires list media network. No, let's go from here. Capture, because I closed it. So option, hide. You have to hide this wireless network connection. Start it. Then go to that particular website. It's loaded. Then go to the Wireshark. Stop it. As you can see here, which one was there, like how many HTTP DNS message you are getting. So this is also HTTP. So let's filter only HTTP packets. So we have this much. So let's have the frequently asked questions related to this. Is your browser running HTTP version 1.0 or 1.1? What version of HTTP is the server running? As you can see, my browser is running. This is my IP address, right? So my browser is running 1.1. Okay, and like even the server also running 1.1. Okay, 1.1 HTTP version. Everything related to HTTP, all the detail about all the packets you can find out from here. You just open it and you will see whatever you need. Okay, so information about everything like headers, flags, differentiated services, version number, header length, etc. Then time, source, destination, then related to the frame. You have everything in different. So let's have another example.
Hi guys, this is Varun here. I'm going to continue with DNS, IP and ICMP. First I'm going to do ipconfig and NS lookup in the command prompt. So I type ipconfig. This gives my IPv4 address, default gateway address. My IPv4 address is 10.251.149.161, and then I'm going to do NS lookup. Okay, NS lookup gives my default DNS server address, which is 202.83.21.24. Now meanwhile I'm going to start with Wireshark. As usual, I'm going to select the interface and start packet capturing. I open the browser, I type ietf.org and I come back to Wireshark. I stop packet capturing. I'm doing this on DNS, so I need all the DNS packets. So I'm going to filter all the DNS. As you can see, there are DNS standard query messages and standard query response messages. So basically the first thing about DNS is all the DNS packets are sent through UDP, not TCP. So UDP is user datagram protocol, which is a connectionless protocol. The other one is TCP, transmission control protocol, which is connection oriented protocol. The difference is TCP has sequence numbers and UDP don't have sequence number. They just have source port, destination port, length and checksum. As you can see, for the standard query message, the destination port is 53, and for the standard query response, the source port is 53. So basically they are traveling through the same port. And the next one I'm going to show you is for standard query in the DNS. As you can see, there are just queries, and here we have one query which is of type A and class IN. Now and we have all other details such as label count, name, length, 15, all this. And you can observe that in the standard query message there are only queries and no answers. And now I'm going to select a standard query response message. Here in the DNS, as you can see, there are queries as well as answers. Here we have one query and we have two answers. Let's see what those answers are. The first answer is, it has name, type, class, time to live, data length, and CNAME, which is a canonical name. So the first answer is basically the canonical name for an alias. The second answer on the other side also has name, type, class, time to live, data length, and address. The second answer is a host address which is of type A. The first answer was of type CNAME. Now I'm going to show you. Meanwhile, I did NS lookup. So NS lookup gave me my default server address, which is 202.83.21.24. As you can see over here, the destination for the standard query is from my computer to the local DNS server. My local computer IP address is 10.251.149.161, which is same as here, 10.251.149.161. The second one is the destination address, which is 202.83.21.24. This is the same as here, 202.83.21.24. This is basically my local DNS server address. So the packets are traveling from my computer to the local DNS server. In the flags also you can see that for a standard query it shows the flag as message is a query. For a standard query response, it shows the flags as message is a response. And we have other flags also over here. We have one question, two answers for the standard query response, and for the standard query we have just one question and 0 answers. And you can also go through other details such as IP protocol. IP protocol, we have version, header length is 20, total length is 61. So therefore you can know that the payload length is total length minus header length, which is 41 bytes. And you can also observe that for different DNS packets, the version, header length and differentiated service field always remains common, doesn't change, and even the total length remains same, but only the ID keeps changing. You can observe the ID over here for different messages. Now it is 16675, now 0x0000, now again it's 16676. so the ID always keeps changing. And you can see the protocol used is UDP, and you have the source address and the destination address. So this is about the DNS. The next thing I'm going to show you is about ICMP. The same packet capture I'm going to show you with the same packet capture. It also has ICMP. ICMP stands for Internet Control Message Protocol. So here we have 3 ICMP packets. The first one, I'm going to take the first one. It also has the same details as frame, Ethernet 2, which gives the destination and source ID, Internet Protocol address. So here the header length is 20 bytes and the total length is 56. So the payload is 56 minus 20, which is 36 bytes. We have all the flags. Reserved bit, don't fragment, more fragments. More fragments is 0, so basically it is not fragmented. The bits our bytes are not fragmented. If at all the bytes are fragmented or the packets are fragmented, the move fragment flag will be set to 1, and here the protocol details as shown is ICMP. We have header checksum which also contains the source and destination addresses. Then we gonna go to ICMP. So ICMP, the message type is 3 and the code is also 3. The message type 3 stands for destination unreachable, the code 3 stands for port unreachable, and we have a checksum over there. Again we have IP version 4, source address, destination address. Here we have header length as 20 and the total length is 78. Now we can see that the packet size is now 78 and the payload size is 58. Also, for all the ICMP packets, you can observe that the source IP and the destination IP always remain same respectively. The source IP of all the ICMP packets are same and the destination IP of all the ICMP packets are also same respectively. Now we can also observe that the version, header length, differentiated services field, total length does not change for all the ICMP messages. They always remain constant for all. As you can see, version is 4, header length 20 bytes, again version is 4, header length 20 bytes, total length 56. Now only the identification changes. Now we can see it is 25374, now 25375, and here 25373. Basically all the ICMP messages will have same version, header length, differentiated services field, total length. Only the identification changes. The next one I'm going to show you is about TCP and UDP, the differences between TCP packets and UDP packets. So I'm going to start packet capturing. I'm going to start the browser. I use ietf.org. Now I come back to packet capturing, I stop. The first thing is I'm going to type TCP. I'm going to filter all the TCP packets, select any one, TCP. As you can see, the TCP packets have source port, destination port, then it has sequence number, acknowledgement number. TCP packets have sequence number and acknowledgement number because TCP is transmission control protocol, which is connection oriented protocol. So in order they need a sequence and also acknowledgement since the packets travel in a sequence. Also you can see the difference in UDP. I'm going to type UDP. UDP messages are contained in DNS. So here I go. See, the UDP packets have only source port and destination port and length and checksum. They do not have sequence number and acknowledgement number because since there is no connection between the two nodes, there is no sequence and order.